Okay, now let's do functionalism today. All right, last time we talked about mind-brain identity theory, what made sense about it, but then also a potential problem that functionalism will try to step in and fix. Okay, so here we go. To introduce this, let me just mention Alan Turing. Okay, many of you will be familiar with him. He was a mathematician, a logician, a philosopher. He worked on decoding codes basically during World War II. He helped the Allies win the war. The Germans thought they had these unbreakable codes because they had these cool code machines that would constantly change the code. So it'd be very difficult, and they just sort of assumed nobody could really crack that. Alan Turing did, and it gave a lot of intelligence to the Allies that helped them win. So very important there, very important in many other areas in life. He came up with the idea of a Turing machine, which is basically a precursor to what we now have as what we now call computer. And for him was a sort of a theoretical model of what a computer could do, just by describing the rules that such a machine would have to follow. And basically that, this theoretical idea very quickly was applied, and we started developing general purpose computers. So this, we can trace all this technology back to multiple sources, really, but Alan Turing was very, very important in this. Um, Unfortunately, later on, he was, because he was a gay man and he was found out at a time when this was illegal. Um, he had a choice. I think it was between imprisonment or chemical castration, and he chose the latter. But a little while after, they found his dead body along with an apple, and they found poison on the apple. So it's possible that his research somehow, he spilled something on there and ate it accidentally. But it seems very likely that it was a suicide caused by severe depression and despair because of this, just outing basically to a world that looked down on it and thought it should be illegal and punishable. Thankfully, we've made some progress since then. So overall, a sad ending to, a brilliant career and a brilliant person. But so it's this idea of a Turing machine that I want to focus on just a little bit. Okay. Here's a Turing machine that I came up with. This is a theoretical model of a Coke machine. Well, just to keep it simple, it only has Cokes. And basically, I'm saying, well, if I had a Coke machine, this is how I want it to function. Right? Let's say a Coke machine, let's say a Coke costs exactly $1. Right? So if it's in the first state and you give it exactly $1, right? This represents the input right here. You can give it quarters or you can give it dollars. Those are the only inputs that it accepts. Okay, so you can input $1 when it's in state one, right? That's its resting state. Its normal state. It's always in state one until you input something. So if you give it $1, well, then it'll just give the Coke. That's what we want. The Coke costs $1, so if you give it $1, a Coke should come out, and that should be the end of the story. And it just stays in that neutral state until somebody else comes along and gives it something. Oh, what if I only had quarters? Well, I'd give it a quarter, right? Input. When it's in state one, I give it a quarter. Then the machine says, okay, if I get a quarter when I'm in state one, I got to change to state two. Okay, so then you're in state two. Now we're going to give it another quarter. When you're in state two and you input a quarter, it'll change to state three. You see how this is working? Yeah. And when you're in state three, it's just sitting there. If you give it another quarter, it'll change to state four. Yeah. And then in state four, you give it another quarter. Well, at this point, you've given it 4 quarters, so then it'll output the Coke and go back to state one. See how that works? So there, it's just a simple, well, if I just had a bunch of quarters, then I got to go through all these stages to get my Coke. If I had $1, it'll give me the Coke right away. What if you're feeding it some quarters, and halfway through, you're in state one, you've given it a quarter. You're in state 2, you've given it a quarter. Now you're in state 3, and you realize, oh, wait a minute, I don't want to use all my quarters. I need those for laundry. I've got a dollar bill. So you've given it 50 cents. You just want the Coke for a dollar. You don't want to use any more quarters. So you're in stage 3, and at this point you decide to change to input a dollar. So you're in state 3, you input a dollar, and then machine instructions say, well, if that happens, I should give the Coke, give the 50 cents back that they already gave, and then change back to state 1. So that way you put the dollar in, you get the Coke, you also get your 50 cents back so you can do laundry. Right? So you see that, so that at any stage you want to make sure that if you've given a dollar, you get a Coke. If you've given more than a dollar, you're given a Coke and the change. If you've given less than a dollar, you're not going to get a Coke. Right? It's a very simple machine. So I don't have this machine. I didn't make it. But if I wanted a functional Coke machine that gave you a Coke every time you gave it a dollar and gave you change every time you gave more than a dollar and doesn't give you a Coke when you don't give a dollar, then this is what it would have to look like, right? This is what it might look like. So we've got these internal states. Depending on where you are, depending on what state it is, it's going to take an input and give an output. And the output is going to be something like give 50 cents, give a Coke, give 75 cents, whatever it is, or change back to state 1, or change to state 3. Those are all outputs, right? These are things that happen as a result of the input. And what happens depends on what state the machine is in, okay? Very simple Turing machine, right? So all vending machines have to work something like that, right? It's always a matter of, if you don't give enough money, you won't get the product. If you give too much money, it'll give you change. If you give just the right amount, it'll give you the product that you want, right? So that's always going to be the case when you have these kinds of machines. Your input changes the internal states and gives some sort of output as a result. And depending on where the state is, it'll give a different output, right? So if a Coke is a dollar and you've given this machine 3 quarters, it's not going to do anything. But if you give it a quarter when it's in that state of having already had $3, 3 quarters, then next output will be a Coke. Yeah, you see that? So we have a machine that takes inputs and translates them to outputs. What kind of output it translates the input to depends on what state the machine is in internally. Okay? So just keep that in mind. It's the same sort of thing as on your phone, right? It's my favorite example. Phone. There we go. The same sort of thing, right? You tap the screen. That's an input. And then something happens on your screen. That's an output. Right? So if it's like this, if it's just my home page and I have to unlock it, then I know the input should be this. Right? Now it's open. Right? And then I could tap on, my favorite, Facebook. Right? I can tap on the Facebook app, and then I get the output of Facebook. Right? And then I can do more stuff on there. I can tap more on the screen, more little inputs. And the kind of output it gives me, the phone that gives me, depends on what state it is in. Right? So if I tap the screen in the middle right now, it'll open one of these apps. If I already have Facebook up and I tap it in the middle of the screen, something else will happen. Right? So it just depends on what state it is in, but it's basically always taking inputs and translating them to outputs. Something is happening inside of the phone, right, that's taking the input and translating it to the output. And what kind of translation happens depends on the state that the phone is in. Okay, I hope that's clear. Keep that in mind. You don't necessarily know what this has to do with the mind yet, but just explaining basically how computers work, right? The basic idea behind it. Okay, so yeah, keep this as background information, just this idea of, it could be a simple vending machine, it could be something more complicated, like a phone, but the idea here is that we have these kinds of machines that behave on the basis of input. and that behave differently depending on what state they are in. Right? So now we get to functionalism. Okay, so functionalism is our third physicalist theory of the mind. Right? Again, physicalist theory of the mind is one that tries to get away from the Cartesian substance dualism model, where the mind is a non-physical entity. Physicalists say, well, let's take the approach where the mind does not get defined in such a way that we cannot study it empirically. Right? So there's different ways of doing that. We looked at behaviorism and identity theory, and we saw sort of some of the problems that both of them had. So functionalism tries to fix that. It's still a paradigm position in many departments, not just in philosophy, but also in psychology in general. Right? That this is the approach. You don't know what it is yet, right? But I'm just telling you, functionalism is going strong still. As a way of thinking about the mind and as a way of organizing the research, right? Your basic background assumptions. It's very much a strong force still, functionalism, in philosophy of mind and in psychology in general. Okay, so to explain what we mean by functionalism and how it's different from identity theory, let's look at the difference between two types of identity. Okay, compositional identity versus functional identity. It's so often these things sound complicated, but then when you hear what they are, it's actually quite simple. Right? So let's talk about compositional identity first. What makes a diamond rather than an amethyst? Right? This is a diamond, not an amethyst. What's the difference? What makes this different from the amethyst? What defines this as a diamond? And the answer seems to be that it's a diamond in virtue of its composition. What is it made of? Well, it's made of these carbon molecules, arranged in a certain way. It's the composition that matters here. Right? Or what makes water water? Well, water, as we talked about last time, water is H2O. It's composed entirely of H2O. So what makes this water rather than wood? Well, it's the molecules that compose it are different. They're different molecules. What makes this water rather than air? Different molecules. It's made of different stuff. Compositional identity. All right. Well, here, what's the difference between a pine table and an oak table? They're both tables. You can sit at both of them. They're both flat surfaces. Well, it's very obvious, of course, what is different. It's right here, right? Pine and oak. Oops. One is composed of pine, the other of oak. So compositional identity allows us to distinguish between the two. What it's made of is different. This is defined by what it's made of. This is defined by what it's made of. They're both tables. It's the same there, but their composition is different. So compositional identity is just a matter of, well, we have this concept of identity where we can identify or specify or define things according to what they're made of. Simple, right? Yeah. Well, contrast that to functional identity, which is a different way of picking out objects and things. Ask yourself, what makes a mousetrap a mousetrap? Is it what it's made of? No, it's anything that can trap a mouse. Right? It's right there in the name. It's its function that matters. Can it trap a mouse? And that's what it's made for? Then it's a mousetrap. Right? So nowadays, mousetraps don't often even look like this anymore, and they're often more humane. They could just be a cardboard box that traps a mouse or something like that. Right? So it doesn't even have to have this mechanism. As long as it traps the mouse, then it's a mousetrap. It doesn't matter what you make it out of. Now, of course, it matters a little bit what you make it out of, right? I don't think you can make a mousetrap out of air molecules. that's probably not going to work. So there are limitations. But the point here is that it's not compositional identity. What defines a mousetrap is not what it's made of. Right? The way that water, it can only be made of H2O. That's what water is. This is different over here. Mousetraps can be made out of different materials. Or a heart. What makes something a heart rather than a liver? Well, it's the functional role that the heart plays in the organism, right? Hearts do different things than livers do. That's what specifies what a heart is rather than a liver, okay? That's why we call artificial hearts hearts still, even though they're not made of the same stuff as biological hearts are. They're made of completely different stuff. We still call it a heart because it plays that functional role within the organism, you know? Another way to explain functional identity. How do we distinguish between tables and chairs? Not necessarily the stuff it's made of. It could be made out of the same stuff. No, it's rather the function that its form lends itself to. Right? A table is something you sit at. A chair is something you sit on. Right? It doesn't really matter what you make it out of. Again, within reason. Again, you can't make a chair out of air molecules, I don't think. Right? But still, you can make it out of metal. You can make it out of plastic. You can make it out of wood. The same thing is true of tables. What makes a table different from a chair is not necessarily what it's composed of, but rather what sort of functional role it is able to play, what it's good for. Yeah? So there we have it. Two different kinds of ways of identifying or specifying something, of saying what defines it. Compositional identity, where something's defined by what it's made of, by its composition. And then functional identity, where something's defined by what its function is, what it does. Okay, so keep that in mind. Then we can just simply think of functionalism as the theory that mental states are defined by their function or the functional role they play, not by what they're made of. Remember, the mind-brain identity theorist said mental states are brain states, just like water is H2O. Right? So they are using compositional identity to define the mind. They're saying the mind is this kind of physical system, i.e. the brain, right? Just in the same way that water is defined by its being H2O, so the mind is defined by its being a brain. And mental states are defined as being brain states. So it's a bit like the mind-brain identity theorist is saying that what's important to the mind is what it's made of. A functionalist is going to disagree. Mental states are defined by their functional role. It's like tables are defined by their functional role. And so it doesn't matter much how you get that role. As long as you have that function, then that's all you need, right? Just in the same way that a table, something can be a table and be made of plastic or wood or metal or something else, as long as it has the function of a table. And so the same thing is going to be true of the mind, according to the functionalist. Right? So functionalists accept mental states as these inner states. They don't just ignore it like the behaviorists do. So they're on board with identity theorists there, at least, because the identity theorist also says, yeah, we need to talk about those inner mental states, things like pain. So functionalism is good on that front. It doesn't just ignore a whole thing that we're supposed to be trying to explain. And it allows for multiple realizability of mental states. I remember this whole thing about aliens or an octopus or something like that. We want to be able to say that perhaps they could have mental states just like ours. But if the mind-brain identity theorist is right, then they cannot, because their mental states would be composed of something different, namely alien brains or octopus brains. And so we can't have the same mental states on that view. On functionalism, you can. As long as that mental state plays the same functional role, that's all you need. Right? Let me see. What else did I want to say about that? No, it's okay. So we can go back to this, the vending machine example. Let's see. Right. The behaviorist is sort of in the position of saying, we can't get to the inside of the machine. All we can really do is study the way, the kinds of output we get depending on the kinds of input we give it. That's all we can really do. The inside is a black box we can't study. All we can study is what happens when you put coins in this. What happens when you put this many coins? What happens when you push this button after you put this many coins in? Right? What happens when you push that button after you put a certain amount of coins in? And then what happens? What kind of output do you get depending on the inputs? That's the behaviorist model. Just sort of ignore it all, the inside. The functional is saying, no. Look, if we can get to the inside, then we can understand exactly what is happening, how it takes an input and then gives a particular kind of output. So we can do science of the mind. We can go inside of the brain to figure out how it does that. All right. So again, behaviorism says, no, we can't get to the inside. All we can really do is study the inputs and the outputs. The functionalist says, no. And now with brain science, we can actually look at the way that the brain does it. We can empirically investigate the way that the brain takes inputs to the outputs. Right? And those brain processes they're functional states. They are ways of taking input and translating it into an output. Mental states are functional states, according to functionalism. Right? So mental states here are defined in terms of what they do with a particular input, right? Either given by the environment or by other mental states. Sometimes you have these internal kinds of relations that makes it a bit more complicated, but you can at least think of it in a very simple way of, for example, pinch myself and I say, ow. All right. Okay. Pinching is the input. The feeling of pain is the functional states that leads to my going, ow. It is what translates the input to an output. Yeah. So if you want to define a particular mental state, it's not about finding a particular brain state. It's just finding out what causal role it plays in the organism. So, for example, if you have an octopus with a very different kinds of nervous system, different kind of brain, still when the octopus, or let's say an alien, when the alien gets pinched and they go, ow, right? Pain is playing the same kind of functional role, so it's pain. It doesn't matter that the alien has a different kind of brain. What matters is what kind of role it's playing in their behavior and in their interaction with the environment. So mental states are causally related to an input from the environment, or again from other mental states, and an output, which is usually behavior, but it could also be other mental states. Right? So it's a little bit complicated, but human beings are complicated, right? So here's an example. Again, pain. It can be causally related to body tissue damage, right? The input. I say I pinch myself really, really hard, where it causes some sort of damage. And then there's pain behavior. It's the output. That's me going, ow, rubbing it or something like that. But there's also other mental states that play a role in my rubbing it, for example, right? So maybe I want to get rid of the pain and I have a belief that rubbing it or applying pressure will help, right? So the initial feeling of pain then brought about other mental states, and those mental states also play a role in my behavior. So the output doesn't have to just be a behavior. The output could be another kind of mental state. In the same way that way back here, go back to our vending machine. Oh, go back right here. Right, say you're in state 2. You've given it 1 quarter. Then if you give it another quarter, there's not going to be an output here yet. You're not going to get change. You're not going to get a Coke yet. there'll be an internal change, right? It'll go to another internal state. So the output there is within the machine itself. It still counts as an output because you gave it an input and something changed, right? So it's kind of complicated, but it really does make sense. And human beings are like that as well. So basically, don't just think that output has to be just the behavioral component in human beings. Just like an output doesn't have to be just change or a Coke, an output can be internal as well. I know it's weird to think of an output as being internal, but an output means an input was given and something changed, right? So in the same way that that happens with vending machines, that happens with us as well. I mean, think about inputs and what they do to your behavior depending on what mood you're in. Say there's something kind of annoying that someone often does, a kind of a behavior that your friend engages in, but most of the time you can just sort of shrug it off. I mean, your mental state is one of equanimity, right? You're at peace, and so some annoying behavior, you're not going to let it affect you. But sometimes you're just not in the mood for it, right? Sometimes you're in a different state. You might be a little more sensitive, or you might just not have patience for a certain kind of BS, right? So the same input can produce different behaviors in you depending on what state you're in. So I think this rings true. That I think that's correct to say that the way that you are connected to your environment is a matter of, okay, the environment is causing you to be in certain mental states. Those mental states produce other mental states, and all those mental states produce different kinds of behavior. How you translate an input to a behavioral output will have to do with what mental state you're already in, right? Like I said, if your patience is wearing thin, it's going to be different than when you're just at peace or something like that, right? Or the way that a chore might sound really difficult if you're sick. I'm like that for sure, right? If I get even a little bit sick, I just get lazy and I don't want to do anything. So I get the same set of inputs. I've got all these responsibilities that are weighing on my mind, but yet it doesn't get translated to the same kind of output because of my mental state. So that's basically what the functionalist is saying. It's kind of a complicated system view. You could think of brains as computers, right? Think of brains as complicated vending machines even. Right? Computer software, it's all about its functional role. Right? We talked about this already, right? Gave the example of Facebook on my phone. What makes it Facebook is not the underlying hardware in my particular phone. If that were true, then only I would have Facebook. It can't be identical to that. So it's got to be identical to something else. And what is it? Well, it's the way in which Facebook uniquely takes certain input and gives you certain outputs as a visual display, and has a set of functionalities that other apps do not. Okay, that's what defines it. So it can be implemented on different physical systems. What makes it what it is, what makes a particular app what it is, what makes a particular mental state or mental capacity what it is its overall functional role within the organism. Okay, that's what functionalism says. Mental states are defined in terms of their functional roles, just like software is. And yes, software needs hardware, so this is in no way a dualist theory. This is not saying that the brain is not important or that you don't need it. You do. You need some sort of physical system to get that functionality. It's just that that functionality theoretically could be realized in different systems. Right. So theoretically, if you can get a computer to translate inputs to outputs in the same way as a human being, theoretically, then that would be a thinking machine. It would be a thinking computer. Right? The computer would have a mind on this point of view, on this view. Because again, if the mind is purely defined in terms of what it does with inputs, how it translates inputs to outputs, and if you can get a system to do that just in the same way as a brain does, then the functionalist is going to have to say that that system would have a mind. And for some people, that result is totally welcome. They say, yeah, why couldn't a computer be conscious? Why couldn't a computer have a mind? Other people will say that that's actually an objection. They'd say, well, if functionalism implies that computers could be conscious, then functionalism can't be right, because computers can't be conscious. So it sort of depends on what your background assumptions are. And tie this back to Turing. If you've heard of the Turing test, it's basically a way of testing whether or not a computer program is intelligent. It's not quite whether it's conscious or whether it has a mind. It just tests for intelligence. The idea is, well, if a computer program can give all the right answers just like a human can, then it is intelligent. If it can play the same kind of functional roles, if it has the same functionality, then it's basically the same thing. Right? And you might then extend this to other things as well. So if you built a robot that sort of looks like a human being, think of a Westworld scenario, right? And that machine, right, it's also made of synthetic material, but it can take inputs and translate them to outputs just as well as human beings can, and they're indistinguishable from another human being. So they might walk among us. According to functionalism, if that's the case, then they are just as much a person with a mind as we are. They would have to have consciousness as well, because if functionalism is right, then all aspects of the mind are to be understood in terms of functionality. And so it wouldn't matter in what system this functionality was implemented. To say that a robot couldn't be conscious, if you're thinking like a functionalist, that's just a kind of a bias. There's no reason to say that. It would be like an alien, right? So now imagine that you have one of these robots that looks just like a human being, that acts just like it, and you have an alien, and they both stub their toe. You're likely to think that the alien does feel pain if you see them engaging in pain behavior. Maybe you're not as biased towards towards aliens. But then if you say, well, but the robot, even though it's engaging in the same behavior, doesn't really feel pain, well, to the functionalist, that would just be a kind of a bias. Right? So basically, on this view, yeah, our brains are like computers. The mind is like software. And our mental capacities are defined by their functions, by the way in which they take inputs and translate them to outputs. Yeah, does that make sense, everybody? I hope. Why am I asking? You can't respond. Okay, let me go. One of the main objections to functionalism. There's different ways of doing this objection, and we'll look at a few more when I look at objections to physicalism in general. But let's look at this one first. This is the Chinese nation counterexample. So first, let's take something more mundane. Let's go back to my Facebook app. So what allows me to use my Facebook app is, well, I give it a certain input, certain tap, 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 and then I get a certain output. What makes it do that? Well, it's just very complicated wiring down here, all these electrical signals, and I don't know how that works, but there's some sort of physical system that allows for that to happen. It takes those inputs and it translates them. And it's basically like the vending machine diagram that I showed you, right? If the phone is in this state and you get this input, then you get this results. Then if you're in that state and you give it another input, then something else happens. Very complicated. Now let's imagine that instead of physical hardware taking those inputs and then translating it to the right kind of display, we instead send those inputs to a very large nation, say all the people of China. I don't know why they picked China for this. Maybe just it's a large nation. You would need lots and lots of people. What if they take that input Yeah. And they mimic the hardware that's on my phone. Because again, the hardware is just a bunch of, it's all in binary, right? It's just on off switches. If this happens, then this happens. If this happens, then this happens. So what if we had people simulating that? Theoretically, you could do that, and that would be fine, right? If they could then give the right kind of output, send it back to my phone, so that my phone knows what to display. Right, so we have all these people involved in this huge thing. This can never happen in real life, but you can imagine it. Right, so again, what we're imagining here is that all these people are simulating basically what the hardware on my phone would do to give me the output. And so the end result, well, that would be fine. If my Facebook still worked every time I tapped, even though it would be this very complicated thing of sending those inputs to this nation and all those people working with each other to make sure we get the right output at the end, that would be fine. Then we'd still say, okay, well, that's Facebook. We said that Facebook could be implemented on different systems. It could be implemented on a phone. It can be implemented on a computer. It can be implemented on a different kind of phone. It could be implemented in the nation of China on this view, right? Because all you need is the functionality. All you need to make sure is that all these people are translating the inputs to the outputs in the correct way. And as long as you get that functionality, then you've got your Facebook. Okay, no theoretical metaphysical problem there. It's a little bit hard to imagine what that would be like, but that would be okay if somehow all these people could take the inputs in the right way and give the right kinds of outputs so that I still have my Facebook app functionality. Okay, we got our Facebook still working. It's just implemented in a different system. Okay, but what if you took this large nation and had it simulate your brain processes? Again, your brain on functionalism is a super fancy computer that's taking inputs and then applying all these rules to get a certain output, right? Like the vending machine. If you're in this state and you get this input and this is the output, but it's very complicated for brains, but still, it's a system with a set of rules that translates inputs to outputs. So then, if instead of a brain, let's say you took out your brain, and all the nerve signals get sent to this nation, and then they translate those nerve signals into some sort of output, and then it gets put back to you. Now we're supposed to ask, would this nation somehow be conscious then? Would it be a mind? The intuition that you're supposed to get on this objection is no. Maybe you could take a whole nation to simulate Facebook and you'd still have a Facebook app. But if you took a whole group of people to simulate brain activity, you wouldn't then get a mind out of it. You certainly wouldn't get consciousness out of it, like as though this is an individual person with a particular point of view, with mental states just like any person. And the intuition's supposed to be no, that would not work. Yeah, do you see the problem here? Right. Functionalist says you should be able to implement functionalities in different physical systems and get the same results. So all mental states are just these functionalities that can be implemented in different systems. This objection says, okay, imagine that the system, instead of a brain, is a large group of people, and you're implementing it on that system instead. Could you get the same functionality? Would we call that a mind? Would we call those mental states? It's kind of difficult to imagine how that would be the case. It's certainly almost impossible to imagine this whole group of people who are mimicking or, somehow recreating what the brain does. It's difficult to think of that group of people as being conscious or of, say, feeling pain, right? Again, if it's just a matter of translating inputs to the right kind of behavior out here, would we say that this whole group of people is in pain in some way? That seems really problematic, right? So that's the main objection there. One of the ways of objecting to it anyway. There's different ways of doing the same thing where you can try to say, well, you can have some physical system that has the same kind of functionality, and yet we would not want to say that it has a mind or that it's conscious. Okay. You might want to think about objections to this objection. It might be something like, what I was saying earlier, that it doesn't much matter what you make a mousetrap out of, as long as it can trap a mouse. But it matters a little bit. You can't make mousetraps out of anything. So you might say it doesn't much matter what you implement a mind on, what the type of functionalities that minds have. It doesn't much matter what kind of physical system you implement it on, but perhaps it matters a little bit, and you simply cannot get the functionality if you have a bunch of people trying to beat a physical system. Maybe that just doesn't work. Right? It might work if it's computer hardware or something like that, and you put it inside of an actual simulation of an organism, or rather some sort of robot or something like that that interacts with its environment just as a human being does. You'd get farther there than you would with this, because maybe this is like trying to make a mousetrap out of air. Maybe that just wouldn't work. And so the fact that this wouldn't work is not necessarily an objection to functionalism, because again, functionalism doesn't say that it doesn't matter at all how you implement certain functionalities. Right? The physical substratum matters to getting those functionalities. Right? Okay, that's it for now. Hope that made some bit of sense. Enjoy the rest of your day. Bye.